Hello and good morning. So as we begin with our continuation of the univariate data unit, we're going to start talking about data distribution. And so we're going to be able to plot graphs and tables and things such as that to be able to see your data correctly. So first off, we're going to start talking about something that you've probably seen before, and that's right here. This is called one of two things. You can call it a dot plot, or you can call it a line plot. Okay, so either one of those is correct. But in order to create one of these, we are going to have a number line, and it's usually going to start off with your minimum number in the set and your maximum number in the set. Now, you don't always have to go by ones. You don't always have to go 10, 11, 12, 13, 14, 15, 16, 17, so on. You can actually do it by twos. You can do 10, 12, 14, 16. That's all going to depend on the data that you have in the set. But it's usually distributed in a certain manner, and that's going to be called the skew. So if we look at our first set, our first graph, we notice that this dot plot or line plot is skewed to the right. I like to remember this by saying that it's sloped to the right. You can also say that it is symmetric, which means it slopes in both directions. And then skewed to the left, I like to call this slope to the left, okay, because it slopes to the left direction. So that's your distribution. That's how your data is distributed in a table. Now, it also may have a extreme minimum or maximum that doesn't fit within the box and with the other values in that set or in that box. Okay, so we like to call that out of the box or called an outlier. Okay, and there's a way that you can actually determine if an outlier is a part of that set by saying that the value x is an outlier if it's below this number or it's above this number. So or below this number or above this number. Now, in order to figure out this number, you're going to take Q1. Remember that Q1 and Q3, those are your quartiles. Oh, I can't even put that there. Those are your quartiles. Okay. Let me see. Let me see if I can write it down here. Quartiles, which we've talked about in the previous video. If you haven't watched that, I highly suggest going back to that because this is not going to make sense if you don't. Then Q1, so that's your first quartile, minus 3 halves times the IQR. Remember, IQR is your inner quartile range. And to find your inner quartile range, like we talked about in the previous video, is Q3, quartile 3, minus quartile 1. That'll give you your inner quartile range. So let's do an example of this together. So we have a data set, and we need to follow a few steps in order to find out if a number is an outlier of this set. So first off, we need to find quartile 1. Well, remember that quartile 1 is the median of your first half. So we're going to just split our numbers in half because we have 6. And the median of the first half is 11. So that's our quartile 1. Then the median of the second half, or the upper half, is 21. So that's quartile 3. Well, in order to find our inner quartile range, it's going to be quartile 3, which was 21, minus quartile 1, which was 11. Now we need to calculate these two numbers to see where our outlier will fall below or where it will fall above. So let's start with this one. So quartile 1 is 11. So let's see, 11 minus 3 halves times our interquartile range. Well, we figured out our interquartile range was 21 minus 11, which is 10. So 3/2 times 10. Okay, so then you'll solve that. 3/2 times 10, that'll be 3 times 10, which will be 30 over 2. 30 over 2, you may have already figured out, is 15. So 11 minus 15 equals -4. So it needs to be below -4, or, now let's figure out where it would need to be above. So quartile 3 is going to be, we've already determined, is 21 plus 3/2 times the interquartile range, which we discovered was 10. Part of this part of the problem we've already done, okay? So we already know that this ends up being 30 over 2. Bring that plus 21 down. Well, 30 divided by 2 is 15, so 21 plus 15 equals 36. Okay? So our outlier can either be below -4 or above 36. Okay? So then that is where your outliers will fall. So that answers that next question. Then we need to determine what an outlier would be in this data set. Well, think of a number that's below -4. So you might have said, -8. Or larger than 36. Well, a number that's larger than 36 might be 40. So those are two numbers that could be outliers. Now, any number that is below -4 or above 36 will be an outlier in this situation. So now I want you to pause this video and I want you to complete example number 2 on your own. So at this point, you should have already completed this. So you're going to make a dot plot of the data, and I'm not really going to go over the answers of each problem, but I am going to tell you how to do each problem. So making a dot plot, remember that you're going to have a line, a number line. Okay, and you're going to number these off. I noticed that this set goes from 20, I think 20 is the lowest number, to 65. So I would probably have my numbers or my segments by 5, so 25, 30, etc. Like I said, I'm not going to complete that. And then you're going to put each value with an X above it or a dot. Okay. Finding the mean. Remember, to find the mean, you're taking an average. So that's going to be the sum of all your numbers divided by the quantity of numbers that you have. Okay, finding the median, remember you're going to put them in order from least to greatest and then find the middle. And then your IQR, so that's going to be quartile 3 minus quartile 1. In order to find the quartiles, quartile 3 is the median from the second half, and quartile 1 is the median from the first half. Okay? And then the last question asks you, if you were to add the number 100 to your data set, would it be an outlier? So you'll have to go back and add 100 to the data set and check to see if your quartiles change. They may or they may not change, but you're going to see if those quartiles change. And then you're going to find the new interquartile range. That number may also not change, but it may. Once you've done that, you'll determine, your range of where your outliers could be. Is it going to be below a certain number and above a certain number? And then see, is 100 below that certain number or is it above? And that will determine if 100 is an outlier. sums up our video for today. So you have your guide to go along with it, and I will see you in the next one.